So in the third part of these dimension analysis videos, we're going to take a look at problems that are more realistic to what you're going to see as you move forward. Like I said, these problems aren't they're designed to just give you practice with dimensional analysis. So a lot of unit conversions don't make sense when you get to the end. But these are a little bit more realistic. And so you're going to see a little bit of twist on the question. A lot of times questions will include conversion factors for you that you need to use. And now here's where you got to pay attention to significant figures and conversion factors when they're the result of something measured and not just a true relationship. So first question, you've got a car traveling at a speed of 113.7 kilometers per hour. How long will it take the car to travel 2,500 kilometers? Don't solve this with a ratio. You've got to use dimensional analysis. That's the whole idea behind this lesson, is to learn how to use dimensional analysis to convert units. So just because this is the first number that you get to in the question doesn't mean that's where you start. You have to find the question. Okay? A car traveling at a speed of blah, blah, blah. There's no question there. That's just a piece of information. This is a piece of information that you are going to use to help you solve the problem, but it is not the question. How long will it take? There's a question. How long will it take? Time. How long will it take a car to travel 2,500 kilometers? There's your question. So what am I starting with? I'm starting with 2,500 kilometers. That's my given measurement, and that's what I'm trying to find an answer to, a related unit. So 2,500, notice there's a decimal point there, so I've got 4 sig figs here. Kilometers, and that's all I have, right? There's no unit on the bottom. So put it over 1. Don't put it over 1. It doesn't matter, but you got to realize there's nothing in the denominator at this point. But I've got this conversion factor, 113.7 kilometers per hour, is something that I'm going to use because look at what the question says. How long is a time if the car travels 2,500 kilometers? There's a distance. So I am going to use this speed as a conversion factor. So kilometers is the unit that I'm starting with. So I'm going to stick the kilometer part on bottom, 113.7 kilometers, and I've got hour on top. Now, how long? It doesn't really specify what unit we want, so let's just solve it and go to hours. Remember, it's per 1 hour in the numerator. Let's solve it and go to hours, and if the number makes sense, then we're done. If it's a really small number of hours, maybe we want to convert it to minutes or something. But at this point, I'm going to take 2,500 divided by 113.7, and I get 21.9876869. So I want 4 sig figs. 21.987 becomes 21.99 hours. So if you think about it, that's a much simpler problem. Oops, equals. It's a much simpler problem than the ones we were doing at the end of the last video. But it takes a little bit more thinking because so many times kids want to start with this first number because it's the first one they come to. If you start with that first number and you write 113.7 kilometers per hour, and then you multiply it by kilometers, well, I've got to put kilometers in the bottom, and kilometers will cancel out, and I'm going to get, look at my unit, it's going to be hour to the -1. It's going to be per hour. That's not what you want. You're going to get a super small number here because you're solving for the inverse. Okay? I don't want you to do it this way and just flip the number. I want you to be astute enough to realize that this conversion factor is not where you're starting. Okay? So this is wrong. Don't do that. I got 2 more for us to try. Okay, so here we've got a reaction is occurring at a steady rate of 4.91 grams per minute. What mass can be produced in 5,000 seconds? Okay, again, this is a conversion factor. It's got some sig figs in it because we've gotten it from doing some measurements, so that's going to contribute to sig figs. Oh, by the way, looking back up at this one, 4 sig figs here, but I still have 4 sig figs here, so I'm going to have 4 in my answer. Now, this one, starting off with 5,000 seconds, but I only have 3 sig figs in this conversion factor that I know is based on measurements and stuff, so my answer is only going to have 3 in this case. Okay, don't start with this question though. Start with the time. I have 5,000 seconds. Again, I write SEC instead of just S. I don't know why. Okay, what mass can be produced? So I want mass. So how am I going to use this conversion factor? I'm in seconds. This conversion factor is minutes. So first thing I want to do is get from seconds to minutes. Then I can use this conversion factor. What mass? Grams is a mass. So in this case, I can write this conversion factor just the way it's been presented to me. 4.91 grams in the numerator, minutes in the denominator. Seconds cancel, minutes cancel. I'm left with grams, which is good because the question is what mass? Grams is a mass. So I've got 5,000 divided by 60 times 4.91 gives me 409.1666666 repeating. Okay, 3 sig figs because of that conversion factor is based on measurements. So 409 grams. That's where I'm going to quit it. 3 sig figs. Okay, so even though there's 4 sig figs here, because this is definitely due to measurements, it's not, we're not dealing with true numbers, it's going to help control my my sig figs in my answer. Okay, so this is an example where you would have lucked out if you started with this number. But hopefully you're seeing how there's no question attached to this number. It's just a piece of information. It's giving you a conversion factor to use. Okay, last one. What is the volume in liters of a 10.36 kilogram sample of a substance which has a density of 1.74 grams per centimeter cubed? Okay, what's the volume of a 10.36 kilogram sample? There's your question. What's the density for? A conversion factor. So again, this obviously came from measurement and stuff, so we're going to use this for sig figs. But I'm going to start with the mass. So 10.36 kilograms. My density's in grams. So I've got to get to grams first. So I'm going to convert kilograms to grams. Then I can use this density. But since grams are in the numerator, I want the 1.74 grams in the denominator. Centimeters cubed in the numerator. Okay, I got to get to liters. If you remember from one of the previous problems, we know that 1 centimeter cubed is equal to 1 milliliter. So now I'm in a volume that is a liter volume. All of these guys have canceled out at this point. All I have to do is go to from milliliters to liters, and I can get my answer. So if you notice, I got 1,000 in the numerator, I got 1,000 in the denominator. Those two guys are going to cancel out. So what I'm really doing is taking 10.36 and divided it by 1.74, and that's all I have to do. And I get 5.954022, blah, 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 blah. This is going to dictate 5.95. And that is liters of whatever that sample is. It won't be long before you're also putting down actually what the chemical is, but in this case we just want to make sure that you can get the units labeled and not the substance labeled right now. Alright, so you've got 3 videos. that have lots and lots of examples. We're going to spend some time working on dimensional analysis, so feel free to refer back to these. And if you want to make notes on the organizers that you've been keeping, which problems are covered in which video, you could do that. I'm going to go back and show you. So this is video 1. The first page was video 1. Second page, it works out nicely. Second page was video 2, so it's where I put multiple units. It's where I used squares and cubes to introduce units. And then obviously video 3 we did was the more realistic questions. So you've got these 3 resources as well as the notes that you took from the videos to help you with all the problems that you're going to be asked to work on after you get done watching the video.